We're going to add in, sorry, I had to make sure I was recording. We have to add in variables to all of these exponents, or with the exponents. We're going to look at roots and estimating roots. Hold on. Is that the second energy drink you pulled out of your bag? Okay, I want you to put that on the desk up at the front. You can have it when I'm done teaching. I'm totally serious, yeah. I'm not letting you drink 2 Monster energy drinks in my classroom.
He drinks 2 triple
I don't care.
per class.
Yeah, no. No. No, you don't. No.
For the age of
Here we go. So this is what we call a power. The whole thing together is in power notation. Power has 2 pieces. It's got the base and the exponent. The base is that guy right there. The exponent is that little guy right there. So what is together, that power tells us to do something. What does that power tell us to do, Oliver? Nope. Colt? What does this expression tell us to do? Yes, you multiply 2 by itself 3 times. Yes. So as you can see, which I did kind of write down here, the exponent represents how many times the base is repeatedly multiplied. So 2 cubed is going to be, and I'm actually going to write it off here on the side, is going to be equal to 2 times 2 times 2. So the base is the number that is repeatedly multiplied. And the exponent is how many times the base is multiplied. So as far as like the development of math goes, addition and subtraction is where everything started. Because the reason math became a thing was because of the world of, well, agriculture and finance. I have this many things, I owe you this many things, you owe me this many things, and now all of a sudden we're adding and subtracting. That is where math started. So then, as math goes on, we're like, okay, well, multiplication becomes a thing, because what multiplication does is it takes repeated addition and it makes it simpler. If I have 2 plus 2 plus 2, well, 2 plus 2 plus 2 is 6. Well, I can just rewrite that as 2 times 3. Well, what have I done? I've taken 2 and I'm multiplying it by 3, and that idea of multiplying is just repeated addition. 2 times 3 is 6. Please don't whistle. Likewise, exponents are just repeated multiplication. We took an operation we do a lot of, and we condensed it into newer notation. Allows us to shortcut the way we think about this stuff, allows us to do more advanced things. This right here, if this was power notation, this right here is repeated multiplication. Multiplication slash, also known as expanded form. What is 2 times 2 times 2? It is not 6. It is 8. And this now has a name. This thing is called evaluated or standard form. So the exponent represents how many times the base is repeatedly multiplied. So again, 2 cubed is 2 times 2 times 2 times 2. That equal sign should not be there because 2 times 2 times 2 is not equal to 5 squared. 5 squared then is just going to be 5 times 5, which happens to be 25. If I have 3 3's multiplying again, this shouldn't be here. My bad. If I have 4 3's multiplied together, how can I condense this into exponential notation or power notation? It would, in fact, be 3 to the power of 4, you bet. What would this one be? 7 to the power of 3. 7 is being repeatedly multiplied. 3 times. Cool.
7 cubed.
Also known as 7 cubed. That's right. So we have names for some of these things. When we square something, that's the same as putting it to the power of 2. This is 5 squared. Or 5 to the power of. That's how we would read that. Good afternoon. No, she's also not in this room. This is still Dweedoff. This is the same extension you tried earlier. I don't know why. So the other two, that room, Black's room, Abe's old room, and my room all have the same extension listed, and the only correct one is mine. So I don't know how hard it is to figure out that 3061 is on there multiple times, but it is. Yeah, but it's not your job to put the phone list together. You know how lost we are with the proper without the proper person down there? I have no idea how to get a hold of that particular room. I'm sorry. You should email her and then have her call you. I'm sure by the time we're done having this conversation, she'll be in class. So okay. No worries. You have a good weekend. Bye. Okay, 5 squared or 5 to the power of 2. As Jackson already said, putting something to the power of 3 is cubing something for reasons we'll talk about in a bit. This is 7 cubed. Okay, so if you don't have a calculator, I want you to get one. All y'all need a calculator right now. Get yours out. If you're coming to get one from me, you must put a phone in the slot you take the calculator from. Do not get a calculator for another person. No, do not get a calculator for another person.
What if I don't have a phone?
Then you go up to the front and you leave me a shoe.
But I don't want to.
A phone or a shoe? Where's your phone?
I have a phone.
You got shoes?
Yeah.
Leave me a shoe. A phone or a shoe?
Can I leave my glasses?
No. Those are my phones now. A phone or a shoe? If I don't get my calculators back, deal. That's the whole reason I take the phones. Leave me a shoe or leave me a phone. I prefer the phones. Something that ties you to this. Okay, here we go. So, these calculators, ladies and gentlemen, guys, all behave slightly differently. So let me show you what I mean. Every calculator works a little. There's the button that says on. Every calculator works a little differently. Here's what you need to know as far as using the exponents go. Hands up if you have a Casio in front of you. Okay, so Casios have 3 buttons for doing this. There is one best button. They have a squared button for squaring things. They have a cube button for cubing things. But then they have a box button. This is the button here I want you guys to get comfortable with. X to the power of box. Here's how you use it. For example, let's say we wanted to cube 2. I'm going to put 2, and then I'm going to push the X to the box button, and it's going to open up this notation. Hands up if you have a TI. If your calculator says TI, yeah. Texas Instruments, yeah. So on the Texas Instruments calculator, you're actually looking for that button. That symbol is on a button. That's what you're looking for.
I got it.
Sorry? It looks just like that one. It has an up arrow.
Mine's actually got a box.
What do you mean yours is a box there?
Look.
No, yours is the Casio. Yours does this.
Yeah, I know. But look.
Yeah.
It actually has a box.
Oh, nice.
And then you
How come this one doesn't? Hold on. Bring that back. Bring that back.
Yeah.
What do I have to do? How do I do that?
I don't know. Just do the box.
I did the box. I pushed the
Wait, I
box.
just did it.
Okay, Casios also do this, guys. Look at this. So Casios, except we're doing 2, not 3. 2, box. Okay, so I'll give this back to you in a second,
Okay, yeah.
obviously. I'll get to your calculator in a second. So if I'm cubing it, On this Casio, I don't know why this Casio is different than this Casio, but it is. I'm going to put my 3 there, and if it's got the brackets, I'm going to close the brackets. On the pink calculator on the right, I'm going to push the 3, and then to get out of the exponent, I just have to push the arrow over to the right, and it boots me out of the exponent if I have more bed mass to do, for example. Either way, it doesn't matter which notation. If I hit equals, both of them should give me 8. Gershon, you had a question?
I have a Casio calculator, but I don't have that button.
You don't have either of these buttons, the box button?
No, we have different ones.
Okay, then TI calculators.
It's not booting.
Okay, so
It's not there.
okay, so then Gershon. Yes. The one that actually, this symbol here. You're looking for one that has that symbol, the arrow up. Oliver, is that what you found on Gershon's calculator? Yeah. So the TIs will have this. Some of the Casios apparently have this. The arrow up button. So it goes 2 to the power of. There is a third option. Guys, some of them look like this. They'll say X to the Y. It means the same thing. I think that's what the Sharp calculators do, I think. So Raven, you have an X to the Y button on yours?
Yeah.
Okay, so that's how you would use this. You'd push 2, and then you push the X to the Y button. You'd push your 3, and then you hit enter, and it'll give you your 2 to the power beta 3.
Equals 8.
Get better, good.
I don't think so.
Okay, does anyone have a different kind of calculator? Yours says what?
That's what we all do.
Yeah, don't use the cube button. I want you to use the general exponent button. Yeah, don't use those. This is what I started by saying. Some of these calculators are going to have a squared and a cube button. Don't use those. Use the general exponent button.
He doesn't have one.
He has to have one. Hayden, what kind of calculator do you have?
Sorry.
They should then try this. Is there an X to the Y button?
This is why it's the X.
Well, it sounds awfully similar. See if it'll work. Is that a 2-line display? Okay. So you have a Y to the X button.
X3 and Y.
Don't use them.
But what if it starts just right?
Not everything is cubed. You have to learn how to use the other ones that aren't cubed. For example, these 4. Use whatever calculator you have at your disposal. I want you to crank these 4 out right now. On your market set, go. I want all of you to know how to use your calculator. Here are your answers.
I don't know what you're doing on yours. Yeah, I actually put over there.
That is not 625.
5 times 5 is 25. 25 times 5
Is 125.
Why X is 5 times 5 is going to be 5. Yeah, no, it is. 625. It is 625.
Do all 4. I want all 4. I don't want you to tell me what the answers are. I'm going to tell you what the answers are. I want you, Raven. I want you to do all 4 of those. Go. Get your fingers out of your chair. Is your fingers stuck?
54.
And we'll get to the church class.
Focus, Raven. These are the values you're looking for. Can you find those values? All of you need to make sure your calculators can get these values.
Yeah, 64.
We did it. Well, he did it. And
You need to do it.
I did it. I actually did it.
Marcus, did you do it?
Yeah, he did the ones after the first one.
Okay. As long as you all know how to use the tools at your disposal. Okay. Ladies in the middle. We good? Emma and Brio? Emma. We good? Okay. So, flip the page.
Page is
Sort of, sometimes. I'm going to take them away for parts of this chapter.
No.
Here we go. So, negatives get a little bit complicated with exponents. And we're not going to use negatives in exponents because that's grade 10 apparently. I don't know why we can't just do it now. I do it with my pre-diploma 9s. It's not that hard. But there used to be. So, yeah. Anyway, what we're going to deal with now, though, is negatives in the base. How that happens, we need bed mass for, believe it or not. So bed mass is important. Jackson, nobody asked you. Okay, here we go. We're going to go up here. This first one, I'm going to write down -2 to the power of 3, and we're going to talk about what this means. We don't just toss negatives in front of things. To make something negative, what mathematical operation has to happen? No. Not division. Well, division and the other one are the same thing. We're going to multiply by what? Negative? No. 1. So when you have something like this, if I have -2 cubed and it's written like this, what this actually means is I have -1 times 2 cubed. That is what this means. Yes. No, that's not 1 point, that's times. That's -1 times 2 cubed. Well, first we're going to write it as, so guys, bed mass here becomes important now. If bed mass says I do brackets exponents, then I divide and multiply. So exponents first means if I'm writing it like this, that 3 exponent gets applied to just the 2, and then the -1 gets multiplied onto that. So I'm going to write this thing as -1 times, I'm going to write the 2 cubed expanded, 2 times 2 times 2. Sometimes you'll just see it written like this, -2 times 2 times 2. But what you need to recognize when you see that, guys, Oliver, I want just you facing the front. Your whole body facing the front wall. Yeah, but I don't want you talking to Gabe or Hayden. That's a lie and you know it. Sometimes you'll see it written like this. The important thing to recognize is what's being repeatedly multiplied is the 2. That negative sign's not on everything. Yes, Jackson.
Oh, nothing was.
Okay. So in this case, as it is written, the base is not -2, the base is just 2. The exponent is 3. Expanded, we're going to write it as -1 times 2 times 2 times 2. The slash here, like an or. Sometimes you'll see it like this, -2 times 2 times 2. You'll see it either way. But this is really how I want you to think about it. And in the standard form, Marcus, you already said that this is -8. When we bring in brackets, things change. So I'm going to go this way. The second one. I've got -2 in brackets now, and I'm cubing it. Well, bed mass says brackets happen first. And so when I'm containing this thing within the brackets, really what's going on here is I've got the -2 cubed is going to become -1 times 2, and I'm cubing that whole thing. Like, think about that minus sign as an entire operation. And when you do that, it becomes a lot easier to recognize what's going on here. This then, it's gonna feel a little repetitive. The -1 times the 2 is what's gonna happen here first, because the math inside the brackets has to happen. So I'm gonna get -2 cubed, and now I'm gonna apply the exponent. The exponent says whatever the exponent is on gets repeatedly multiplied. So this thing's gonna become -2 times -2 times -2. So the addition of brackets in a question like this changes things. So now when I've got the brackets there, my base is everything within those brackets. So this is going to be -2. My exponent is then 3, which is going to make this -2 times -2 times -2, which is also going to be, is it going to be positive or negative? If I have a negative times a negative, that's going to be positive, times another negative is negative. So this is still -8. So why does it matter that we had that conversation? Well, hold that thought. We'll come to it in a second. Let's take a look at the next two. I've got -5 squared and I've got -5 squared. Well, it sounded like I said it the same way, but I didn't. What's the base in a question like this? Sorry? It's 5. The base is 5. There is no bracket to contain the negative. The exponent is just on the 5. The exponent is 2. So I can write this as negative 1 times 5 times 5. Sometimes you'll just see this as negative 5 times 5. You need to recognize that the thing being repeatedly multiplied is 5. How many times? Twice. And then you toss the minus sign out front. And then in standard form, this thing's also going to be negative. In this case, it's negative 25. All these answers are all still negative. It's weird. So the last one. I've got negative 5. This time it's in brackets. So that because it's in brackets, it's going to be considered part of the base. So I've got my negative 5 there. I'm squaring it. So how is what I'm about to write down going to be different than what I wrote down previously? Yeah, Gershon. Yeah. I'm going to have negative 5 times negative 5, and in this case, it's going to give me positive 25. So the brackets are always important, but where do the brackets really make a difference? They make a difference when the exponents are what? Do you think it's just going to happen when it's 2? We said 2, and then we said 2 and 4, and now you said all of the evens. Yes. All of the evens. So I'm going to jump down here. When you have an even number of negatives multiplied, i.e., you have a negative value with an even exponent, that will always give you a positive value. The negatives will always be able to pair to something positive. And an odd number of negatives multiplied is, that shouldn't say is give, it should just say gives. Gives a negative answer. So when the negative sign is outside the bracket, we don't repeat it.
Is this English class now?
No. When it's inside the bracket, I mean, there's the fact that this isn't an English class, and then there's like embarrassing mistakes. That's an embarrassing mistake. You should. All y'all who should read, who can read, that should bother you. Wait, what? Did I really just hear that? That's really sad. That's really sad. What do you mean you guys don't read?
I can't remember the last time I read a book. Like,
I don't remember the last time.
That makes me really sad.
No, I do. Last year in English. I don't remember it. I honestly do not remember. We had to read The Outsider.
That's the last book you read?
That is the last book I read.
That's really sad.
Yeah. We're kind of brainwashed.
Or brain dead.
Probably not.
Here we go. I am aware. I did attendance already. So, fractional bases work the same way. It doesn't matter what's inside the base. We treat it the same way as we would anything with an exponent on it. So if I have 1/2 cubed, that's the same thing as writing it as 1/2 times 1/2 times 1/2. It doesn't matter that it's a fraction. We treat it the same way. So what's that going to be? 1 times 1, how do we multiply fractions? We just go across the top, Oliver turn around, and we go across the bottom. So 1 times 1 times 1 is, and 2 times 2 times 2 is 8. Cool. Did it wrong.
Are
Are you allowed to do what? No, I want you to write them as fractions. You need to be able to show me you can do this with fractions. That's okay. I believe in you. You can do it. You're going to have to do it. Okay, so next one. 2/3 to the power of 4 is 2/3 times 2/3 times 2/3 times 2/3. I'm just repeatedly multiplying by whatever the base is, as many times as the exponents say to. But if you look at what's going on here, when I multiply fractions, I just multiply everything in the numerator and I multiply everything in the denominator. So I'm going to write this out. This is going to be 2 times 2 times 2 times 2 all over 3 times 3 times 3 times 3. I could rewrite that in a different form of exponent notation. If I have 4 2's repeatedly multiplied together, how could I write that? I could write it like a 16, or I could write it like, I just kept writing. How many 2's do I have multiplied together? 4 of them. So I could write this as 2 to the 4 over 3 to the 4. This is an exponent law you guys were supposed to learn in grade 8. When I have a fraction, look at what's happening here though. It kind of follows, guys. When I have a fraction to an exponent, well, what ends up happening? What happens is that exponent on the outside ends up applying to the numerator and it ends up applying to the denominator. Oliver, turn around. Jackson. Oliver. Oliver already said this was 16. What's 3 to the 4? No calculator. It's not 57. It is 81. How'd you do it? There's a really simple way to do it. If I don't let you guys have calculators,
81.
I told you not a calculator. Way to catch up. Look how there's a simple way to do this, guys. I have 3 times 3 times 3 times 3. 3 times 3 is? This 3 times 3 is? 9 times 9 is? You don't need a calculator for that. Okay. Jackson, put the calculator. Yes, I did. Okay.
Wait, can I get my shoe back then?
Raven, what's your question?
I thought that was a negative 9.
No, that's... I'm multiplying. Okay. Negative 3 cubed is going to be negative 1 over 3 times negative 1 over 3 times negative 1 over 3. I did tell you that when you had negative fractions, to just absorb that minus sign up into the numerator. Bring it on up. So this is just going to give us negative 1 times negative 1 times negative 1 over 3 times 3 times 3. Which is going to be what? Yeah. No. So close. Negative 1 over 27. There's three negatives. Okay. What time does block actually end? I think you guys are way fast. Is it 1:15?
Yep, I checked on the app.
I'm also going to check on the app. It's also 1:15. Okay, so what I want you to do is flip the page. And I want you to crank out this.
Just wait.
On your market set, go.
You'll say, please go back.
Flip the page to page 3. I want you to do all of page 3.
No.
Yeah, you can use a calculator.
Yay.
Put it back. What?
Is he another one? No way.
Oh, please.
Oh, he's taking both of them now.
Get to work.
He took them both of them.
No more energy drinks in math class. Not zero.
Can I have some?
No energy drinks in math class. No. Because some people already have a hard enough time paying attention. People who are hard time, if you have not proved to me that you know how to pay attention in math class, you don't get energy drinks. So no energy drinks.
If I do this, like,
No. You need to go more than a whole class length of time without me having to stop turning back.
You should know what it is.
I've been silent though.
Get to work.
You should know what it is.
I'm supposed to work. Bro, what is this? It's just a bunch of X.
want you to work on it.
Is that what?
Yeah, I'm doing the each stage, but like the meaning of that gives it up. So you use calculator just for the standard form section. X times X.
So it's just 7 times 7?
Multiplying X by X by X by X.
7 times.
That's why it's zero. You can't evaluate.
Oh, so you just X.
No? How many X's are there?
Oh.
Let me guess. 7.
There are 4 of them, so it's going to be X squared.
So y to the 6.
No, it's X.
What's y to the 6?
Why do you have me on your story? Think about what Hayden's done and try and apply it.
No.
Hayden gets work.
Okay, who took one?
I. No! Slap music. It's gonna hit me.
Get to work. Hayden, get to work. Jackson, you shouldn't even know that he's going to hit you because you shouldn't be looking at him because you have work you need to do. So face the front and do your work.
Sorry,
You know what? That'll be a lingering fear for you. Then that's okay. Be afraid.
He has that face.
You shouldn't even see his face. He shouldn't be looking at
He
you.
looks happy.
Yeah.
I don't want to see his face.
Yeah. Yes, you may. And the back of his head is totally benign. So there'll be no slapping as long as he doesn't see your face. It's really easy. Oh my gosh. Third block on a Friday, man.
Can we go home now?
No. Here we go. That's the first chunk. Comments, questions, concerns, Jackson and Oliver, questions on any of these first half?
Wait.
Oliver, stop talking. I will show everyone the last chunk in a second. Okay, Charlie, we good? We checking our act? Brielle, we're good? Okay. So let's slide these down. Are there any questions about any of these? I know 5 or the one with the 5s. The 4th one down can be a little tricky. Again, if you approach it like we've been approaching things, that negative is in the brackets, it's getting repeatedly multiplied. This negative is out front, it's not included. It's the same as multiplying by -1. Write it out like this, and then evaluate. Here's that chunk. I'm very intentionally not showing the last one. I want everyone together for the last one.
Look, I was right. You need to erase the question.
No, I got it.
But it doesn't make sense what the result is. If you think about it like that, it doesn't make sense. Okay, no, hold, stop, Marcus. You're not multiplying by 0. Okay, are we good? Can I show you the last one now? Okay, I'm waiting.
I got everything right except 1, 2.
How many numbers are that number was never there?
I know. I got everything right except number 2.
I don't know how you do it. Like, how would you break that down?
Okay, here we go. Last ones. So, when I've got 12,345 to the power of 0, before we jump into that, I'm going to write down 12,045 to the power of 1. I want you to write that down. Let's talk about what this means. The base is 12,345. The exponent is 1. So how do I write something as repeated multiplication with itself just once? Well, how we write this one is just 12,345. It isn't actually going to end up being multiplied by itself at all. It's just going to be itself. It just is. So that's also then what standard form is going to look like. 12,345. Where things get a little weird is when we've got things to the power of 0. The base stays the same. The exponent is now 0. How do I write the expanded form for something not multiplied by itself at all. In the expanded form, there conceptually, it doesn't make sense what this would be. I'm going to end class with an argument about what this is. Here we go. I want to show you what this is. You know what? No, stop talking. I want you to learn. Stop talking. I want you to learn. Okay, so 3 cubed. 3 cubed is what? 3 times 3 times 3 is 27. Okay, so 3 squared is 3 times 3, which is 9. How do I get from 27 down to 9? Divide by 3. Okay, for a second, I'll think you're supposed to be the first. How do I divide? 3. It's funny, I like it. So let's do it again. If I have 3 to the 1, that's just going to be 3, which is 3. I divided by 3 to get down here. Well, if I'm dividing by 3 to get down here, look what I'm doing here. I'm dividing by 3 and it's dropping the exponent each time, right? So if I go to drop this exponent down to 0, we're going to divide by 3 again. That's going to take me to 3 to the 0. I'm going to divide by 3 again. That's going to take me to 1. Anything to the power of 0, doesn't matter what that number is, and you may not go anywhere. Anything to the power of 0 is never going to be 1. Anything, does not matter what's here. Okay, that box should have a 1 in it. You may pack up after that happens. Okay, if you borrowed a calculator from me, return the calculator and take either your phone or your shoe.
Can I have my shoe back?
If I get my calculator back, you can have your shoe back. Okay, this is a 1.
You can have my shoe if I